Alright, so for question 4, a regular octagon with side lengths of 3 units is inscribed in a circle with a radius of 4 units. What is the area of the octagon? So the formula of the area of a regular polygon uses the length of the apothem and the length of one of the sides of the polygon. However, you can still find the area of a regular polygon if you cut the figure into triangles where each side of the polygon is one side of the triangle, and each triangle has a vertex at the center of the polygon. So each triangle has the vertex at a center, and each one ends up on the polygon at the vertex. And that creates our triangle right there. So if you cut the octagon into 8 triangles to describe, you can state that the triangles are congruent to each other by the blank, which congruency postulate or theorem correctly fills in the blank in the previous sentence. Well, if this is talking about right here, this outside circle, since this segment intersects the outside of the circle and it begins at the center, this is a radius. And every radius in a circle, remember we're looking at this circle all the way out here, not the blue one, but the circle. Circles, all the radiuses are the same. So if you were to look at this, we know that this is 4. So that means since it's on the circle and it starts in the center, every other radius is going to be 4. And we also have this angle would be the same if you take 360 degrees and divide it by 8, because we're breaking it up into 8 triangles. Each one of these would be 45 degrees. So we have a side angle side congruence postulate. Okay, well, that is one way. They're saying that there's another way too. The other way is knowing that every side of a regular polygon is the same length. So this side would be 3, this side would be 3, this side would be 3. So you would have this radius and this radius, which is 4. So you would have side, side, side. Again, you would have a side, side, and again, this is a radius, so it's 4. So you would have side, side, side as well. So both of those could be a reason why you knew you had had congruent triangles. I think if there's more than one correct answer, it ought to be an option as well. I apologize for that. Because the triangles are congruent, you can find the area of one triangle and then multiply that value by the number of triangles to find in the area of an octagon. Start by finding the area of triangle ABM. In order to do this, you need to find the measure of angle AMB. So we already found that because I had explained to you the side angle side. So we took, again to recap, since there's 8 triangles, that means each of these angles breaks up 360 degrees. So 360 divided by 8 leaves us with 45 degrees. So that angle is 45 degrees. So step 3, now that you have the measures of 2 sides and the included angle in one of the triangles, you can find the area of the triangle. So we have this side given. We also know this side because it is a radius, because we have a point on the circle and it starts at the center, just like this one does. So that segment is 4. So for the formula, again, we would have 1/2 because we're using triangles and we're not trying to find the area of the square, rectangle, or parallelogram. So 1/2 times the 2 sandwiching side lengths, which is 4 times 4 times sine of 45 degrees, because that's our sandwiched angle. So we have 1/2 times 4 times 4 times sine of 45 degrees. Make sure you're in degrees. 5.656 to the nearest hundredth. Since this is a 6, it rounds this one up to a 6. So 5.66 units. There we go. So what is the area of the regular octagon? Well, since our area for one of the triangles was 5.66, and we know that there are 8 of these triangles, there's 1, 2, 3, 4, 5, 6, 7, and 8. We can take this area of one triangle, multiply it by how many triangles we have, which is 8, and we would find out the area of the octagon, which is 45.28. So that is for question 4.